So in this video, I'm going to go over Unit 6, Section 4, and we're going to talk about triangle similarity with angle, angle, side, 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 and side, angle, side. So first we're going to go through this warm-up just to remember how to do these types of problems. And when we do these, if you guys recall, we cross multiply. So we would do 6 times b and multiply that times 11 times 8, which is 88. And then we would divide the 6 into the 88, and that would get us 14 2/3, which is 14.67. Here, again, we've got z times z, and that equals 100. That would be z squared equals 100. And so we would take square root of z squared and take the square root of 100. That would give us plus or minus 10. Over here with number 3, we would multiply 10 times 6 and set that equal to, so this would be 10 times 6 equals 3 times x plus 12. So this would be 60 equals 3x plus 36. So that would be 24 equals 3x, because we would have subtracted the 36 from both sides. So for number 3, x equals 8. When we talk about number 4, it says if triangle QRS is similar to triangle XYZ, identify the pairs of congruent angles and write 3 proportions using pairs of corresponding angles. So here we just look at what letter is in what position relative to what letter in what position in the second one. So Q maps to X, R maps to Y, and S maps to Z. So that means that angle Q and X are congruent, R and Y are congruent, and S and T are congruent. Then we're talking about sides. So QR is over XY, RS is over YZ, and YS is over XZ. So in this lesson, we're going to prove that certain triangles are similar by using angle, angle, side, 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 and side, angle, side. And we're going to use triangle similarity to solve problems. So if you recall, when we talked about congruence, all the parts of a triangle, all the angles and all the sides are congruent when we talk about congruence. However, there are 2 conditions that need to be satisfied if we're going to have 2 triangles that are similar. And when we're talking about similar triangles, their angles are still congruent, but their sides are proportional. So we're going to use that as we work through some of these shortcuts. So here it says there are several ways to prove certain triangles are similar. The following postulate, as well as side, 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 and side, angle, side similarity theorems, will be used in proofs, just as side, 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 angle, side, angle, hypotenuse leg, and angle, angle, side were used to prove triangle congruence. So if you notice here, we have that angle A is congruent to angle D. So that's one of our pairs of angles. So angle A is congruent to angle D. And then we have B is congruent to E. Angle B is congruent to angle D. Now we know these 2 triangles are similar because by the third angles theorem, we also know that C is congruent to F. And as I've shown you guys many times, that if a triangle just gets bigger, then it is automatically similar if the angles are congruent. So now let's use this in a problem here. So it says explain why the triangles are similar and write a similarity statement. So the first thing we can see here is that angle A is congruent with angle D. Then you should also be able to see here that the vertical angles are congruent. So we know that these 2 angles are congruent that I just marked. So we could say that angle ACB is congruent to angle DCE. Thus, we can say that the 2 triangles are congruent. So triangle ABC is similar, sorry, not congruent, but similar, to triangle. Now, if we look at A has a right angle, so D has a right angle. If we look at B has nothing on it, so that would be E. And then if we look at C has 1 arc on it, so that would be C here as well. And these are similar because we have both angles. So they're similar by angle, angle. The next problem is example 2. This one says explain why the triangles are similar and write a similarity statement. So on this one again we can see that angle B is congruent with angle E, and we have in the left triangle a 43-degree angle and in the right triangle a 47-degree angle. So what we need to do is find the third angle in both of these. So because we have a right triangle, we can just say that 90 minus 43 equals 47 over here. So we know that this is 47 degrees. In the one on the right over here, we're going to say 90 minus 47, and that equals 43. So we know that this is 43 degrees. So now we could say that either one of those other angles, we could say the angle A is congruent to an angle A is 43, so angle D is 43. We could go on to say C is congruent to F as well, but we really only need two angles here to prove that the triangles are similar. So now we're going to talk about a similarity statement. So again, we're going to say triangle A, B, C is similar to triangle. And again, if we start with A, it's 43. So over here on the right, if we look for the 43-degree angle, it's D. And if we look at B, it was our right angle. So on the right, it's E. And then we have 47 for C, and so that would be F over here. And these triangles are similar, again, by the angle-angle postulate. So the next problem here says explain why the triangles are similar and write a similarity statement. I'd like you to try this problem on your own and then come back to me. Put the video on pause and then come back to me. Okay, so now we're going to talk about this. I want to show y'all, first of all, we know that the vertical angles are congruent, so we could say that angle PQT is congruent to angle RQS. We could say that first. Then I want you guys to notice that this side is parallel with this side, and this could be spoken of as a transversal. So we could say as a result of that angle P is congruent to R because they're alternate interior angles. So we could say that angle P is congruent to angle R. And we do have another transversal here that crosses those same lines. We could have also said that angle T is congruent to angle S for the same reason. So we could have said angle T is congruent to angle S. Now, which one of these alternate interior angles you choose doesn't really matter. Then we're going to talk about our similarity statement. And let me go back in here and make one of these. Well, it's fine because they're different colors. So let's just talk through these. So if we say PQT for triangle on the left, so triangle PQT is similar to triangle. Now, if we look at P again, it has one green arc, and R has one green arc. Then if we look at Q, it has one red arc and one red arc, so we're going to put Q here. And then we got two arcs at T and two arcs at S. So we're going to put S over here. Again, the reason these are similar is because of angle. We had two angles. We obviously had three, but we really only need two. All right, so let's go on to this next one. So now we're going to talk about some more properties. So when I teach this, I like to throw some numbers in here because I think it helps people understand a little bit better. So I'm just going to put some numbers here, and then we're going to work through this together. Because again, I think it'll help y'all understand. All right, so when we start comparing these sides, I want to talk about the shortest side to the shortest side. And if you notice, the triangle on the left, the shortest side was 2. And on the triangle on the right, the shortest side was 4. Well, if I look at that ratio, it reduces to be 1/2. Now, if I look at the middle length, that would be AC, so that's 3. Over the middle length over here on the right, which would be DF, and that's 6. That ratio also reduces to be 1/2. And if I look at BC, which is 4, and EF, it's 8. Those are longest to longest. So this also reduces to be 1/2. Now, if you'll notice, all three of these represent sides. So this is a side, and this is a side, and this is a side, and they all produce the same ratio, which means they're proportional. So we could say that these two triangles are similar by side, side, side. Again, they're proportional, producing the same ratio. Now up here again, for example's sake, I'm going to throw some numbers up here. So I'm going to put 3 here and 6 here. I'm going to say that this angle is 60 degrees and this angle is 60 degrees. And I'm going to say that this one is 6 and this one is 12. So let's work through this shape again. So if we start with the 3 and the 6, shortest side and shortest side, 3 over 6, that equals 12. I mean, sorry, 1/2. Yeah, 3 over 6 equals 1/2. Then, if we look at these angles, we can say that angle B, which is 60 degrees, is congruent with angle E. It's also 60 degrees. Then if we look at our last pair of sides, we have BC is 6, that's our longer side, over our longer side of our right triangle, which is 12. This also reduces to be 1/2. So here again, what do we have? We have a pair of sides that produce a ratio. We have angles that are congruent, and we have another pair of sides that produce this same ratio. So in this problem, we could say that these are similar by side, angle, side. So now we're going to do a couple examples of these. All right, so let's look at this one. So the first thing it says, verify that the triangles are similar. So if I look at these two triangles, one of the things that I see immediately is that they're both isosceles triangles. So I notice that both the sides of PQR and STU are, we have a pair of sides that are congruent. So I'm going to put the sides that are congruent, 3 over 4.5, and that actually reduces to be 2/3. And you can put this in your calculator, 3 divided by 4.5, and then push math in 1, and it'll give you that reduced fraction. The other side is the same, 3 over 4.5. That also produces 2/3. And then I have my third side here, the 2 over the 3. Again, we can see that that produces the same ratio. So this is side, side, side. Then all we have to do is talk about what is the similarity statement that we're going to make. So we can say triangle PQR is similar to triangle, and again, if we start with P over here, that's between 2 and 3, so we could say S over here, triangle S, and then we went to the angle that's between the congruent sides, so that would be T over here, and then we finish up with U. And again, the reason that these are similar is by side, 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 because we had the same ratio produced all 3 times. So here's our next problem. Example 4 says verify that the triangles are similar. Now when I do a problem like this again, I'm looking at sides. So I notice that DE is shorter than DF, and I notice that JH is shorter than KH. So we're going to look at short to short and long to long. So over here we've got DE, which is 2, and the short side of the triangle on the right is 1. That produces a ratio of 2. Then I notice that these angles are congruent, D and H, because they're both 70. So angle D is congruent with angle H. And then I've got my other side, my long side here. So I've got 5.8 there and 2.9 there. So I'm going to say 5.8 divided by 2.9, and that also is 2. So again, if we have the same ratio here, which we do, and we have an angle in between, so this is going to be side, angle, side. So let's go ahead and write our similarity statement again. So we're going to say triangle DEF is similar to, and this time we started with 70. So we're going to start with 70 over here. That would be H, and I went across, if I go to D, from D to E, I went across the shorter side. So over here on the right, I'm going to go across the shorter side here. I went across the shorter side here, so I'm going to go across the shorter side here. So that would be J, and then that only leaves K here. And again, these are similar by side, angle, side. Okay, here's the you try. So you guys go ahead and try to do this one on your own and then come back to me when you're done. Okay, hopefully you've already attempted this. Now, the first thing I notice is that this angle is congruent with this angle. And then again, so I'm going to go ahead and work through these sides because I see that over here on the left we have a side, an angle, and then a side. So I'm just going to do it in the order it's in. So I'm going to do the shorter side on the triangle on the left over the shorter side on the right. That actually reduces to be 3/4. Then I could say that angle TXU is congruent. Now these are congruent because they're vertical angles. TXU is congruent to VXW. And then we have our longer side. This is our longer side of this triangle and our longer side over here. So we got 15 over 20. This also reduces to be 3/4. And I notice once again that I have the same ratio here. Important, because that's what allows me then to say that this is going to be similar by side angle side. So let's write our statement again. Triangle. I'm going to say TXU. TXU is similar to triangle. Now again, over here T, I go from T across the shorter side. So that's going to be T across the shorter side, V across the shorter side. So V to X, and then I'm finishing out with W. And again, our reason that these are similar is by side, angle, side. So we're going to use the triangle proportionality theorem proof again. But before we do that, I kind of want to go actually through this like this. So here it says finding the lengths in similar triangles. So now this is the way I like to do this. I like to do the little triangle over the big triangle. So I'm going to write the letters of the little triangle. That would be ABE. ABE. And that's going to be over the big triangle, which with corresponding sides is going to be ACD. Notice here that A is congruent with A. Now I can say that these triangles are similar because they share an angle. So there's the angle that both triangles share. Here's my little triangle, ABE, and here's my big triangle. And both of them share this angle down here at the bottom left, okay? So then we're going to start working through this to see if we can solve for X. So first thing I'm going to do is compare what two sides that I had the measure of. So if you notice, I've got the 9 down here, so that's AB. And then I need to compare that to the whole side of that triangle. So I'm going to have to add these two parts together. 9 plus 3 is 12, so that's going to be over AC. And if you notice up here, AB over AC lines up there. So then I'm going to look at these other two sides. So I've got this side here that corresponds with this side. So that would be EB over DC. And notice here, EB, or I'll do it up here, EB over DC. So EB is 5 and DC is X. Now to solve this, what I'm going to do is I'm going to create a proportion. I'm going to set these equal to each other. 9 over 12 equals 5 over X. Then I just cross multiply. 9X equals 60, because 12 times 5 is 60. So that means X is equal to 6.7. So I need y'all to go ahead and do the next one on your own. Come back to me when you're done. Okay, so once again, you should see that we've got a little triangle here, and that would be RSV, over a big triangle, RTU. And you notice here again that we have R in both, so this angle is congruent in both. So that means that the triangles are similar by angle. So now let's work through this problem. So we have, if you notice up here, we have RS and it maps to RT here. So those are two pairs of sides. So we have 10 over RT. Then we have this side over here on the right. This side maps to this side. So we have SV over TU. So SV is 8, TU is 12. Now we're going to set these ratios equal to each other. So we've got 10 over RT equals 8 over 12. Cross multiply again. That's going to be 8 RT equals 120. When I divide both sides by 8, RT equals 15.